Welcome to my term project short demonstration. As you can see, it is a command-based graphing calculator. So you input different kinds of commands to interact with the calculator, to draw graphs, and to do all kinds of math operations. So the three coolest things this calculator do is as follows. The first thing is graphing. You can call the graph command and pass in whatever function you like. Let's start from some basic functions. Linear functions, polynomials, trig functions, let's say exponential functions. You see the functions are graphed correctly and each with a different color. You can also graph more complicated graphs, say sine x to the square. Sine x to the square. Get a nice graph here. Let's see a few more examples. Some fun compositions. +1. Let's say -5. Okay. Cool, nice little graphs here. Let's do a polynomial. -3x + 4. Cool. So as you can see, the calculator graphs different kind of graphs correctly. You can also do graphs inside a specified domain. So say I want to graph sine x, but only from 0 to 3.14. So I pass in a second parameter, and the function is graphed correctly. Cool. Let's do a final example here. Log x from 0.1 to 2 and from let's say 4 to 6. It's graphed correctly. Cool. Notice how you can also move the axis. So let's say you can move horizontally by calling the movex command and passing whatever number of units you want to move. So I want to move 5 units to the left. I can move right by passing a negative number. I can move vertically as well. Let's say 5. Okay, so I kind of move off grid here. Move y, -17. Okay, we're back. Cool. Notice how you can also move really far off grid. You can say passing -100, so you're moving 100 units. Right. And see how the function is also correctly graphed, and the axis still stays in the frame to kind of indicate the coordinates for you. Let's do a little bit crazy stuff here. Let's also move like 100 units down. You can see we're nowhere close to the origin right now. But see how if I graph a function, say sine x + 95, you'll expect this function to show up somewhere near here. And indeed, it shows up. Cool. You can also scale the axis. And to do this, basically, so scaling works here by changing the unit length from 1 to any other number passing. So say I want to change the unit length to 2. And the function is correctly scaled. If I call in a function here, it's correctly graphed based on the scale of the axis. Now if I change the unit back, both graphs change correctly. Cool. So now that we have gone over graphing, let's move to the second amazing feature here. Differentiation. So to do differentiation, you call the diff command and pass in a function you like. It will return the correct differentiate and stores it in a variable. So now if you want to graph the differentiate, just call graph on the variable itself. And it's correctly drawn. Now let's go diff on log x. Returns whatever x correctly, and let's graph this as well, passing in our own domain. You see the graph is correct. Cool. Of course, can you also do some more complicated differentiations? Say, let's do differentiation on sine x plus log x. Okay, did I make it right? Yes. As you can see, it returns the correct answer. And again, you can graph the differentiate, passing our own domain. Nice graph here. Let's do another example here. Let's say sine cosine x squared minus 1 plus 1 minus plus 1 minus 3. Cool. It also returns the correct answer, even though we are differentiating on some complicated function. Let's grab the graph. A really nice graph, as you can see. Cool. So as you can see, the calculator can do differentiation correctly. Now let's move to the final feature, root finding. So if you graph a function, you want to find its roots. Simply call the root command and pass in the variable in which the function is stored in. And the calculator will display the roots. You can click on the roots to display the actual coordinates. I used a Newton method to do the approximation, and as you can see, the result is pretty accurate. Let's finish off by passing a few more functions and finding the roots. Cosine x. You can find the roots on the second function as well. Interestingly, you can also find the intersections between two functions by calling roots and passing two functions. And now you'll see the intersections are displayed. You can click it up again and see the actual coordinates. Cool. So that's pretty much the basic features of this term project. Thank you very much for watching, and I hope you like it.